I'm now moving on to page 197, and on page 197 I have a few more second derivative extension questions. And for this particular problem, I'm given a cubic function, and it has a point of inflection at the point 2, 8, and I need to find the values of a and b. So the values of a and b can be found in your cubic function right there, and you have to use the information given the problem to find those two values. Okay, so one thing that you have to recognize is that if you're given a point of inflection, which is at the point 2, 8, this point of inflection is actually a real point on the original function there. So 2, 8 is a point on that graph. So if I take my function here, which is y equals to x cubed plus ax squared plus b, I know for a fact that this point 2, 8 is on that graph. So what I can do now is I can label this 2 as the x value, and I can label this 8 as the y value. So this y right here, I can replace that with this 8, and that's going to become 8 equals 2. And anytime I see an x, I can change all these x's with that 2. Okay, so let's do that. So this will be a bracket 2 to the power 3 plus a bracket 2 to the power 2 plus b. And after that, I can simplify this. This will be 8 on the left-hand side. 2 to the power 3 is also 8 plus, well, 2 squared is 4, and 4 times a is 4a, and then plus b. And then I'll finish off by bringing this 8 to the left-hand side. So 8 minus 8 is going to be 0. So 0 equals to 4a plus b. So that is one of my equations that I will need to kind of, I will need this equation for later on in the problem here. Okay, so another thing that you need to recognize is that when you're given a point of an inflection here, that means the second derivative is equal to 0. And this x value, which is 2, that 2 is important. That's because that's the point where that's the x value where the second derivative is equal to 0. That's the definition of the point of inflection. So what you need to do now is you need to take your first derivative right here, your original equation, and you need to find the second derivative. So in order to find the second derivative, you have to find the first derivative, which is going to be 3x squared plus 2ax. And then you need to go ahead and find the second derivative, which is going to be 6x plus 2a. Now remember, this 2a right here, that's just a constant. So a constant times the variable x. If I take the derivative is just a constant, which will be 2a. Okay, so if I'm given the point of inflection, that means the second derivative is equal to 0. And the x value where that happens is at the point 2. So all my x's will now change to 2. So 6 times 2 plus 2a. That would give me 0 equals to 12 plus 2a. Negative 12 on the other side, 2a on the right-hand side. Divide both sides by 2. And that would imply that a would equal to negative 6. Now that we found the value of a being negative 6, I can take my negative 6 and plug that back into this equation. And if I do that, I would get 0 equals to 4 times negative 6 plus b. This would be negative 24 plus b equals to 0, and 24 would equal to b. So those are my values for a and b for that particular problem. Okay, let's move on to the next extension question here. So for question number 2, I have another cubic function, and it has a relative minimum at that point, negative 1, 3, and it also has a point of inflection at x equals to negative 3, and I need to find the values of a, b, and c. So the values of a and b and c are in your original cubic function here. Okay, so if you have a relative minimum right here, what that means is the point negative 1, 3, it's a relative minimum, so it's an actual point on that graph. So just like the previous problem, I can take the point negative 1, 3, I can label this as x, I can label that as y, and I can substitute that back into the original function, which was y equals to x cubed plus ax squared plus bx plus c. So this y value will now change to 3. And all my x values, all these x values will change to -1. So that's going to be -1 cubed plus a times -1 squared plus b times -1 plus c. And then let's go ahead and simplify that. That's going to be 3 equals to -1 plus a minus b plus c. If I take this -1 and move that to the other side, that's going to become positive. So 3 plus 1 is going to be 4. So 4 equals to a minus b plus c. After that, I'm going to box that equation there because I will probably need it for my next step. Okay, so let me just erase all this. And let's continue on and analyze the problem here. Now, another thing that you have to recognize is that when you're given a minimum point at the point -1, 3, this minimum means that the first derivative is equal to 0 at the x value of 1. Okay, so this -1 value, sorry, it's -1 here. That -1 value is important because it implies that when you have a relative minimum, it means that the derivative is equal to 0 at the x value of -1. So let's go ahead and write out my my original function again. And I need to go ahead now and find its derivative. And the derivative, we can write that as y prime equals to 3x squared plus 2ax plus b. Now remember, the values of a and b, they're just constants, right? So just remember that when you're taking the derivative. And since we have a relative minimum, that means that the first derivative is equal to 0, and that happens at the x value of -1. So all my x values will now change to -1. So this will be 3 times -1 squared plus 2a bracket -1 plus b. And if I solve that, I would get 0 equals to 3 minus 2a plus b. And then I can take this 3 and I can move that to the other side. So 0 minus 3 would be -3 equals to -2a plus b. Okay, and I will go ahead and box that guy because that will be important for the final step in this particular problem. Okay, let me just erase this. Let me erase these colors here. All right, the last thing that I want to consider here is this final sentence here. I have a point of inflection at x equals to -3. So if I have a point of inflection, that means my second derivative is equal to 0 at that x value of -3. So I need to take my first derivative here, and I need to go ahead and now find the second derivative and set that equal to 0 when x equals to -3. So if I find my second derivative, that's going to be 6x plus 2a. And since I have this point of inflection, that means the second derivative here is going to be equal to 0 equals to 6. And the x value where that happens is -3. So 6 times -3 plus 2a. And this will allow us to find the value of a. And if I go ahead and keep on solving this, I can take this -18 and bring that to the other side. So 0 plus 18 is going to be 18 equals to 2a, and a would equal to 9. All right, so there's the value of a. A is equal to 9. Then I can take this value of a and plug it in over here. So that's going to be -2 times 9 plus b equals to -3. And that's going to be -3 equals to -18 plus b. And now we can solve for b by taking this -18 and bringing that to the other side. So that would be -3 plus 18, which is going to be positive 15. So b would equal to 15. And finally, I can go back to, I can take this b value of 15, plug it in over there. I can take this, this 9 value here and plug it in for a, and then I can solve for c there. So if I do that, 4 would equal to 9 minus 15 plus c. And let's go ahead and solve that. That's going to be 4 equals to, well, 9 minus 15 is going to be -6 plus c, and c would equal to 10. All right, so that finishes off that particular problem. Okay, let's move on to the last question in this video here, question number 3 here. I'm now moving on to question number 3, and for question number 3, I'm given this quartic function, and it has a horizontal tangent line and a point of inflection at x equals to 1. All right, so for this particular problem, if you're given a horizontal tangent line, that means the first derivative is equal to 0 at x equals to 1. All right, so I need to take my original function, which is this quartic function, x to the power of 4 plus ax squared minus b times ln x. I need to take the derivative of this, and if I take the derivative of this, this will be 4x cubed plus, now 2 times a would be 2ax minus b. Now, b is just a constant, so the constant remains, and then the derivative of ln x, well, the derivative of ln x is 1 over x, and 1 over x times b will be b over x. So that's my first derivative. And because I have this horizontal tangent line here, the horizontal tangent line literally means that the first derivative is equal to 0 when x equals to 1. So all these x values will change to 1. So this will be 4 times 1 cubed plus 2a times 1 minus b over 1. And then we gotta simplify that expression here. So this is gonna be 0 equals to 4 plus 2a minus b. And then I can take my 4 and move it to the other side. So 0 minus 4 would be negative 4 equals to 2a minus b. And let's go ahead and just box that because I'll be using that in a later step in this problem. Okay, let's go back to the original problem here. Let me just erase all this. I don't think that's really necessary anymore. Okay, the next part of this question, we are given that the point of inflection is at x equals to 1. So if you're given a point of inflection, that means that the second derivative is equal to 0 at x equals to 1. Okay, so if this right here, if this box right here in red, if that's my first derivative, I need to go ahead and find the second derivative. So that's f double prime of x equals to, well, 3 times 4 is going to be 12, so 12x squared plus, now remember this 2a, that's a constant, right? So if I'm given a constant times a variable is just going to be the constant. So the derivative of 2ax is going to be 2a minus, now b over x, that's the same thing as b times x to the power minus 1. If I take the derivative, the minus 1 would come in front, so negative b, x to the power negative 2, and that would equal to negative b over x squared. So if I take this guy and replace it over there, this negative sign will now become plus, so plus b over x squared, and that would complete the second derivative. Okay, so let me just erase all that. Okay, so since we're given a point of inflection, that literally means that the second derivative here is equal to 0, and that happens when the x value is equal to 1. So this would be 12 times 1 squared plus 2a plus b over 1, which is just b. And then we can simplify this. This is 0 equals to 12 plus 2a plus b. And then I can take this 12 and move it over to the other side. So 0 minus 12 is going to be negative 12 equals to 2a plus b. Okay, so now I have this equation right here. And now we have two equations and two unknown variables. So this is now a system of equations, and now we need to solve for a and b now. Okay, so let me just move this equation down here. This would be a negative 4 equals to 2a minus b. Okay, let me just get rid of that box there. Now, in order to, I can eliminate the b's right away. The b variables I can eliminate right away by just simply adding these two equations. If I add these two equations, negative 12 plus negative 4 is going to be negative 16. 2a plus 2a is going to be 4a. And positive b minus b, those just cancel off. So I can now divide both sides here by 4. And a would equal to negative 4. Now that a equals to -4, I can take this -4 and plug that in over here. So that's going to be -4 equals to 2 times -4 is -8 minus b. And b would also equal to so negative b would equal to, well, -8. If I bring that to the other side, it would be -4 plus 8, which is going to be +4. And then if I divide both sides by -1 sign, b would equal to -4. So my answers are -4 for A and -4 for B.